Okay, let's get started. Guys in the back, can you hear me? Okay. Today we are going to talk about cues. And I told you about this in the last class. AI Graduate School is holding several events for undergraduate students. We did casual lunch last Friday, and you could have casual conversation with AI Graduate School faculties. And this Friday, we have Open Lab. It is going to be held at AI TED Hall, the building S7 on the second floor. And you could talk about academical things with current MS and PhD students. And you can also have conversation with AI graduate school faculties as well. And you could talk about research projects going on. And you could also talk about research opportunities like interns or graduate studies and etc. Okay, and homework 4 is due on Thursday, and homework 5 will be out on Thursday as well. And regarding midterm, the schedule is fixed. It is on April 16th from 1 p.m. to 3 p.m. And the location is not this room, but the building C, 대학시관, room 104. And the coverage is from Python primer to binary search. We're going to talk about binary search next class. That is going to be our coverage for midterm. And the midterm covers lecture slides and the codes I gave you and the homework problems. However, our homework problems include optional problems, and you don't have to worry about those problems because they are not going to appear in the midterm. And we also, I'm going to include recitation materials to make midterm problems. And the format are as follows. We are going to have 3 types of problems and maybe a total of 7 to 10 problems. One is WWPP problem, what would Python print? And the second format is PPP exercises. I gave you a couple of PPP exercises during lectures. And short answer questions. And the midterm is closed book, closed laptop. So you should bring your pen and eraser. Other than that, you don't need to bring anything. And don't forget to bring your student ID card. Any questions regarding midterm? Okay. And after we discuss binary search, we're going to have a midterm review session. It is on April 9th during class time. It is an optional lecture and it is going to be face-to-face. And you can choose to attend the class or not. I'll just accept questions in Korean regarding lecture materials, and you can ask any questions regarding course materials. And if you have any questions about homework problems, you can attend TA office hours. Regarding homework problems, refer to TA, not me. Okay, any questions regarding course logistics? And you can refer to last year's midterm problems and last year's midterm problems. For those of you who are not aware of this, if you go to the course website, I did not delete last year's materials and 2022, the year of 2022. So you can go there and check the midterm problem here and with the solution, okay? So refer to past midterm problems. Okay, today's main topic is queue. What is queue? We are in a line when we want to take some service, and this is basically what a queue does. So the first come gets the first service. So this guy comes first, gets out of this queue for the first time, and the last guy comes into this queue, gets out of this queue for the last time. So a queue also stores a collection of elements and behaves as a queue of people. Think about lining for some services like ticketing. And as stacks, we can only access to the first element. In the case of stacks, the first element was the top element. However, in the case of queues, the first element is the bottom one. And we get the element from the bottom side, not from the top. That's the difference between stack and queue. And it works on the principle of first in, first out. Okay, let's define queue_ADT, abstract data type. The functionality of a queue is, of course, a constructor. We should be able to create a new queue. And this front method returns the first element, or the element at the front of the queue. And enqueue, or enqueue, pushes a new item into the queue. And this new item becomes the last element rather than the first or top. And dequeue, or deck, returns the element at the front of the queue and removes it from the queue. And the element just next to it becomes the new front element. So it is like pop in the case of stack. And isEmpty method returns true if there are no elements in the queue. Okay, let's compare queues and stacks. They're quite similar. And when we are implementing queues and stacks, we're going to follow a similar strategy. Queues follows the principle of FIFO, first in, first out. Stacks, otherwise, follows the principle of last in, first out. The last item goes on the top, and it gets out of the stack for the first time. In the case of queues, the first item goes into the queue, gets out of the queue for the first time. And we use the term enqueue when we push new items into the queue. And in the case of stacks, we say push. And in the case of queues, we use the term dequeue. And in the case of stacks, we use the term pop. Pop is just getting the first item on the top, and dequeue is getting the first item at the front. And in the case of queues, we should keep track of the first and last items. In the case of stacks, we just need to keep track of just the top item. And applications of queues are like this. You guys use email, and emails are queued. And graphic user interfaces depend upon event queues. So when you click some window for the first time, then that window should react first, then other interfaces. And when you use printers, it is called spooled. Sometimes you might have seen spooling error, and that is basically queue error. The printer does not distinguish whether which one comes first, which one came first. That is when spooling error occurs. And when you transfer data through a network, then those data are buffered. And this buffer means queue. If you request one item to transfer to another network, another location, then that data should be handled for the first time, not other data. And machine instructions are executed using a sophisticated queue known as pipeline. You might learn about this in the computer architecture class. All right, this is the concept of queues, and we're going to implement queues from now on. And queues, similar to stacks, are quite straightforward to understand. It's not that difficult. So we're going to focus on applications of queues. Before we go on to implementation, any questions? Okay, let's move on. By the way, I opened the Zoom, class Zoom. You can join the Zoom if you have any questions, and you can ask questions through the chat, okay? Okay, let's implement queues. Before we implement queues, I'm going to define two errors. The first one is empty queue error. This one occurs when queue is empty, but we want to retrieve some item. Then empty queue error occurs. And this full queue error occurs when we try to get some item, push in queue some item. And when the queue is full, then we cannot push any more item. Then full queue error occurs. And we're going to implement queues using the Python list first. So we're going to define queue. The first one is the constructor. In the case of constructor, we are going to keep track of the data inside this queue. And we will store the number of items inside this queue. And at first, the size should be 0. And the next item we're going to implement is empty method. This one checks whether our queue contains some item or not. And this is simple to implement. We just need to check whether self.size equals 0, or we can just check whether the length of items inside our data equals 0. Either ways are okay, is okay. So that is the second method. And the third method we're going to implement is front. This one does not accept any parameters, but self. When we try to retrieve some item from this queue, and if this queue is empty, then it should raise some errors. So we need to first check if self is empty or not. And if self is empty, we're going to raise empty queue error. Otherwise, we are going to return the first item. So this indicates the first item inside our queue or inside our Python list. And the next thing we're going to implement is dequeue. And we want to retrieve the first item. We also need to check whether our queue contains some items or not. So we're going to use this code again. And before dequeuing, we need to decrement the size by 1. And then we're going to return the first item. When you call this pop method for Python list and pass no parameter like this, then it basically returns the last item, the item at the end. However, if you specify the index, then the specified item will be returned. Okay, so here we are specifying the index of the item we want to retrieve. And the next method is enqueue. We want to push a new item into this queue. And this is simple to implement. We just need to append this item to our internal Python list. And we need to increment the size by 1. And the last method we are going to implement is the size method. We just need to return the internal size. Or we can implement it as like this. However, it will take more time than this one. Okay, that's basically our implementation of queues. It's pretty straightforward and similar to that of stacks. And let's test our queues. First, we create a queue. At the initialization, when we call is empty, it's going to say it's empty. And we can enqueue new item like this. And after we enqueuing, it's going to say it's not empty any longer. And we can also enqueue like 2 and 3. And can print out the front. And we can dequeue. Like this. And we can print queue once again. Okay. Let's run this first. At the initialization step, it says the queue is empty. And after enqueuing 1, it says the queue is not empty. And when we enqueue several items, 2 and 3, it says the front item is 1. And after we dequeue, then the first item comes out for the first time. And the next item, 2, gets out of the queue next time. And because the queue now contains only 3, the front item becomes 3. Okay, that is our queue. Can you see one inefficiency from this code? This code is not very efficient. Can you guess what we can improve about this queue implementation? Sorry? Yeah, that's correct. Nice answer. This is quite hard to detect that this operation takes on, and this operation is quite slow. Internally, this pop operation removes the first item and create new array. And it's going to take on rather than O1. And we want to improve this part. And that is our next topic. So I'm not sure if I mentioned this in the last class, but just remember that pop operation, getting some parameters, is very slow. And only the pop operation for the last item takes O1. So even though this operation is supported by default Python list, it's not that efficient. So you better not use any parameters for pop method if you want to make your program efficient. Okay, let's see how we can improve this part. I'm going to copy this one. And improve this one. Here, we're not going to use this size attribute any longer. What we can do is we are going to have two lists. One is for in and the other is for out. I'm going to tell you what these two lists are doing. Okay, and to check whether, so we basically get items through this in list and sometimes pass the items inside this in list to out. And in doing so, we reverse the order of the items. And when we get items from this queue, we're going to get the first item from this out list. I'm going to show you how we can implement that and how we can improve the efficiency. So let's define special method first. So what I mean by is this. We're going to sort out the items inside the list time to time, from time to time. If self is empty, then we're going to raise empty queue error. Because if there is no item inside this queue, then there's nothing we can do about it. And if the length of self out equals 0, then what we are going to do is we are going to copy the items inside this in list. And after that, we are going to reinitialize this in list as a list containing no item. And after that, we are going to reverse the order of the items inside this out list. And after that, what we can do is to get the front item, we're going to first call this sort out method. And after that, we return the item that is at the end of this out list. Okay. So when front method is called, we're going to sort out the items. And we pass some items inside this in list to this out list. And in doing so, we're going to reverse the order of the items. Then rather than calling it pop 0, we can just get the last item like this. Okay. And when we do dequeue, we're going to first sort out. And we can just remove this 0 index here. And it's going to take 01. And when we enqueue, what we do is to this in list, we're going to append this item. So this one, in fact, does not take 01, but it takes 01 on average. And in the worst case, it can take ON. So it's a slight improvement. Can you guess when the worst case occurs?
그렇게 재료가 쌓이면서 여기 아웃에 아무것도 없는다.
Yeah, that's correct. Nice answer. If you just enqueue all the times and then dequeue, then it's going to take on. However, that rarely occurs. If you enqueue and dequeue and take turns between enqueue and dequeue, then it's going to take O1 on average. Okay. Any questions up to this point?
셀프 게이트가 팝이 아니라 셀프 아웃가 팝은
Which part?
EQ.
Yeah, that is correct. Okay, let's move on. So that was queued using Python list. And from now on, we're going to implement queues using arrays. Why do we care about implementing queues using arrays rather than Python lists? Because you might use other languages when you go to companies or for research centers. Then you might not have access to Python list. In those cases, you need to use arrays to implement queues. And how can you implement queues using arrays? I'll first show you the scheme of implementing queues using arrays. The difference between lists and arrays is that in the case of arrays, the capacity is specified. It is fixed when you initialize the arrays. So you cannot change the size of the arrays. If that is the case, we are going to have none. Let's say the capacity is 5. Like this. And what we are going to do is we are going to keep track of front and rear. And at initialization, the front and rear indicate the same position like this. And when you want to add a new item, initialization with capacity of 5. And when you want to add 5, then at the position of rear, we are going to put 5. And this none becomes 5, like this. And front indicates the first position as before, and rear goes to the next position, like this. So this is what happens when we add one item. And when we add, let's say 8, and 7, then this rear goes this position because we are adding new item at the position indicated by this rear. And what happens when we remove or dequeue, then we remove the item where the front is indicating. So we make this position as none again and move this front one step. So this is what happens when we call dequeue. Okay. And after we add more items, then this rear could go to the front. Like this. Okay. So we can make a circle, and if the front part is empty, then we can add new items at these positions. Okay. And when we add one more item, then rear and front might point to the same point. So in this case, we cannot distinguish whether if front and rear indicate to the same point, then we cannot distinguish whether this queue is full or empty. And to resolve this, we're going to make one space empty all the times. So let's say this position should be none all the times. Okay, so if rear plus 1 equals front, then we say this queue is full and we cannot add any more items. That is how we are going to implement queue using arrays. Okay, that is basically how we can implement queues using arrays. And I'll give you the template. Um, take some time and implement this queue using arrays on your own. And if you try to solve this problem, please send me PPP message.
어떻게요?
Join the Zoom. Or I'll give you just like 7 minutes and try to think about how you can implement this one.
항상 때가 저 배열이 다 쓴 거예요? 아니면 배열 딱 하나만 빼고 다 쓴 거예요?
So think about it on your own. All right, let's solve this problem together. Thank you for sharing your answers. First, we need to create an array to store our data. And we are going to assign the capacity amount of memory for our data array. And next, we are going to initialize the front and rear position as 0. And what is the case when the queue is empty? I told you here that when front and rear point to the same location, that it means the queue is empty. So we just need to check whether front and rear point to the same point, location. And when is the queue is full? When self rear plus 1 equals self front, then it is full. Because we are going to leave one space to distinguish full situation and empty situation. And one thing that we need to think about this implementation is that we want to make our array circular. So when this position is full, when the front positions are empty, then we can turn around front and rear indicators. And to deal with that, front, let's say, rear is here at the end, and front is here. And just ignore this part. And if this is the case, then rear plus 1 equals front. However, because the front is at the front of this array, we need to turn this rear indicator to the front again. And to do so, what we are going to do is, rather than just adding 1, we are going to perform the percent operation like this. And this percent operation can ensure circling around the array. Okay? So that's one thing you need to be cautious about. And what about this front method? We first need to check whether our queue is empty or not. So we are going to check the emptiness of this queue. And after that, we just return the data that is pointed by this front indicator. And how can we dequeue an item from this queue? We're going to get the item at the front like this. And we're going to move the front indicator to the next position by adding 1. However, to deal with the circling around the array, we're going to perform this percent operation like this. Then we can return this item. And what about in queue? To implement this in queue, I haven't. Okay, we need to first check whether this queue is full or not. If this queue is full, then we cannot add any more items. If that is the case, we are going to raise full queue error. If that is not the case, we're going to add new item at the position pointed by the rear pointer. And at this position, we put new item like this. And then we're going to increment rear by 1. And to handle the circulation, we are going to perform this percent operation like this. Any questions regarding this implementation? Okay, let's move on. You should be cautious about this percent operation to support circulation. The next implementation is using linked nodes. So as you can see here, once the data capacity is fixed, then we cannot add more items. And that is somewhat cumbersome and not nice. And as in Python list, we want to support changing the queue size flexibly. And to do so, we can implement this class queue using linked nodes, as we did for stack. So I'm going to first define this node. And you can use this node class to implement queue. In this case, one thing to note here is that we don't have isFull operation because we can add new items by connecting new nodes. So it cannot be full. So that's why we removed isFull method from here. Okay. Think about this question on your own and please send me a PPP message before you tackle this problem. No, you should not have capacity here. All right, thank you for sharing your answers. Let's solve this problem together. There are many ways to implement queues using this node. For example, you can extend this node to doubly linked nodes, but in this problem, we are just using simple node, this one. In the initialization, you first need to implement the front and rear indicator like this. And to check whether this queue is empty or not, we just need to check whether this front equals none or not. If this front contains some item, then it's going to be a node rather than none. And in the case of front, we first need to check whether this queue is empty or not. If this one is empty, we can raise empty queue error. Otherwise, we're going to return the item inside this front node. And when we are dequeuing, let's say front was pointing to some node 1 like this. And the node 1 is connected to another node like this. And when we want to dequeue, what we can do is just disconnect this connection. What we just need to do is just remove this connection. And after dequeuing, it will not contain this F, but these two nodes. Let's say this one was N0, and it was pointed by the front node. Okay, and to implement that behavior, of course, we also need to check whether our queue is empty or not, like this. We first retrieve the item inside this front node, and after that, what we can do is update front to this N1. Originally, front was indicating this node, but we changed the pointer to the next node. And self the front dot next will do what I described. And to enqueue new item, we first need to create a node containing this item. And if this self was empty, then front and rear might indicate point to the same location, same temp node. If that is not the case, we can say rear's next one becomes temp, and the current rear becomes temp. Okay, that's how we enqueue new item. So we are adding new item at the end, like this. Any questions up to this point? Okay, let's move on. I'd like to give you one more problem. I guess we are running out of time, so I'll just describe what this problem is about. And we're going to start from this problem in the next class. This problem is from Facebook's coding test. I'll give you the description. So what you want to do is opening a lock. And this target is the password. And we want to know this function should return the minimum number of turns required to open this lock. And we start from 0, 0, 0, 0, 0, 0. And the dead ends means when we reach here, the lock is going to be broken. So we cannot go further from there. Okay, so that's what dead ends mean and target is about. And what I mean by turning this locked is like this. So we start from 4 zeros. And when you turn this lock in one direction at the first position, then it can become 9. Okay, so that is one way. Or if you turn this lock at the first position on the other way, then it will become 1, 0, 0, 0. And let's say if you turn this lock at the third position on the reverse order, then it becomes 1, 0, 9, 0. And if you turn this one at the fourth position, then it could become 9, 0, 0, 1. Okay, so you need to think about all the combinations and how many turns we need to perform to reach this target, avoiding these dead ends. And you can solve this problem using queues. Okay. And before we finish today's class, I'd like to explain one more thing. Although we have implemented our queues, Python also offers queue interface. You can import this Python queue from collections, import deck or dqueue. And you can use queue like this. However, it uses different names for enqueuing and dequeuing. At the initialization step, you can pass some items like this. Then this queue will be initialized with these items that we specify. And in this queue, we can add new items by using append. We can append 7, 8 like this. So the default Python dequeue uses the term append to synchronize this one with that of Python. So this one is basically enqueue in our implementation. And for dequeue, it uses different name. It says pop left. So this one corresponds to dequeue in our implementation. Okay, so to solve this problem, you can use your own queue implementation, or you can use dequeue. All right, that's it for today. If you have any questions, you can stay here. Otherwise, you can leave now. Thank you for your participation.